Hey guys. All right. Hope you had no problems with that last little bit of work on introduction to chapter 8. Anyway, so this is 8.1. Graphing f of x equals ax squared. So we're getting into quadratics. That's what x squared means. It's quadratic. That's what it's called. So we're going to be able to graph y equals ax squared and describe all the characteristics of it, okay? This is a quadratic function, excuse me. All right? It's a nonlinear function written like this. Like this, only today we are only looking at this part of it, okay? So we're not going to worry about bx and c. We're worried about ax squared. Remember, y is the same as f of x, g of x, h of x. So if you see this written as, hey, f of x equals 5x squared, okay, it means the same thing as y equals 5x squared, okay? This is a parabola. That's the shape it's going to make. What kind of shape is it? It's a U shape. Okay? U-shaped parabola. Going to be asked that? Yeah, probably. Okay? So you got to make sure you know what graph looks like of x squared. And you will after today, I promise you, right? The parent function is f of x equals x squared or y equals x squared. All right? That's where a is 1. So graphing y equals ax squared when a is greater than 0. Let's take a look at this. All right, so we're going to graph it, and then we're going to compare it to x squared. So we're going to graph this, all right? So you might want to just jot this down. Very basic, all right? We got to make a table, okay? If x is here, y is here, we're going to plug x into this right here, and we're going to solve for y, all right? Because this is the same thing as y, all right? So g of x equals 2x squared. We're going to go ahead and graph this. So I would recommend grabbing these points. All right, -2, 1, 0, 1, 2. Then we're going to plug them in. -2 squared, -2 squared times 2. All right. Ultimately, this is what this is going to look like. 2 times -2 squared. All right, so I'm going to square -2. That's going to be 4. 4 times 2 is 8. All right, I'm going to square -1, which is 1. 1 times 2 is 2. I'm going to square 0. 0 times 0 is 0. 0 times 2 is 0. I'm going to square 1 and multiply it by 2. 1 squared is 1 times 2 is 2. I'm going to square 2 and then multiply it by 2. So 2 squared is 4. 4 times 2. Notice I'm squaring first. Order of operations. Got to raise it to the exponent first. I'm not going 2 times -2 and then squaring it. That would be 16, right? 2 times -2 is -4 squared. I get 16. All right, so check it out. 82028. So this is going from -2 on my x's up to 2, and then my y's are this. So let's just go ahead and graph these. First, I'm going to graph 0, 0. Hey, 0, 0. Then I'm going to go to 1, 2, 1, 1, 2. Then I'm going to go 2, 8, 2. Oh, wow. 8's way up here somewhere, all right? What about -1? -1, 2. And -1, -2, 8, way up here, right? So this is going to look like this, all right? So compare it to f of x equals x squared. So what is x squared going to look like? What do you think that's going to look like, all right? So I put in -2, I squared, I get 4. Boom. I put in -1, -1 squared. Hate when that happens. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So look, it's got the same kind of pattern, only not as big numbers, all right? So 0, 1, 1, 1, 0, 0, 2, 4. It's a little bit wider, right? So it's a little wider than this one. So this one's narrower. Narrow. All right. So when A is greater than 0, it opens up, and it's, well, anyway, when it's 2, it's narrower. All right. So here's the skinny on that A. This is good to know. You can look at a graph and figure it out just without even graphing it. If 0 is between, or A is between 0 and 1, if this number right here is between 0 and 1, half, 0.3, 4/5, okay? Those are all numbers between 0 and 1. What are some more? Wow, okay. That's close to all those. All right, so if it's between 0 and 1, then it's going to be wide, right? So instead of being in between here, like if this was 1/4 x squared, it would look like this, okay? Be wider. All right, x squared looks like this all the time. This is x squared, okay? So if a number goes in front of it, it's either going to be inside of it or outside of it. Right? So when it's between 0 and 1, it's outside of it. It's going to be wider. It's called a vertical shrink. Okay, this is acceptable, but you're going to need to know this for your homework. All right, vertical shrink, wider. Vertical shrink, wider. Fair warning, one guess on the homework. No click, check, click, check, click, check. One check is all you're going to get. So make sure you're paying attention to what you're doing. You're not going to be able to just click, check, click, check, click, check. Those of you who aren't watching this right now are going to be in a world of trouble. All right, what happens when A is greater than 1? So this number here is like 2. All right, we put 2 here. What do you think is going to happen? 5, 10, 100, whatever. Something greater than 1, even 1.5. Then it's narrow. It's going to be a narrow opening, okay? What the heck? What the heck? So here's y equals x squared. A is between 0 and 1. It's going to be wide. That's this one, okay? When A is greater than 1, it's going to be inside. It's going to be narrow, okay? Narrow. Stretch. What happens when A is less than 0? All right, so we're going to have two chances here of what's happening with A when it's less than 0. We're going to be between -1 and 0, and we're going to be less than -1. All right, because the same thing is going to happen. Okay, because when A is between -1 and 0, that means it's going to be a fraction or a decimal. All right, -1/2, -0.2, -1.3, -4/5. So that means it's going to open down, which is called an x-axis reflection. And it's going to be a vertical shrink. So it's doing two things now. Now it's opening down. That negative means opens down. All right, negative in front, open down. All right, if it's a number there, disregarding the negative, if it's less than 1, it's going to be wide or a vertical shrink. Now, if A is less than -1, in other words, like -2, -5, -10, then it's going to open down still. It's going to be a vertical, it's going to be a x-axis reflection and a vertical stretch. All right, so try to make sure you're understanding this. So this is going to make it wide, whether it's opening down or up. If it's less than 1, that number, if it's a decimal or a fraction, less than 1, going to be wide or a vertical shrink, right? If that number is bigger than 1, regardless of the negative, all right, and disregarding the negative, if that number is bigger than 1, it's going to be a vertical stretch. It's going to be narrow. A negative means it opens down, all right? So here's another example. So can you tell me what this one's going to do? -1/2. You should know right off the bat, you should be able to look at it and say, this is going to open down. So if you have multiple graphs to choose from, Right? If I had multiple graphs to choose from, if I had this one or this one would be it because it's opening down. All right, so it's going to open down. What else is it going to do? It's going to be a little bit wider because it's less than 1. So this is less than 1. So let's look and see what happens. Again, we're going to pick some numbers. I would not pick an odd number. Why wouldn't you pick an odd number, Mr. Cole? Because what happens with an odd number? 1 squared is 1 times negative 1/2 gives me negative 1/2. I can graph that, but I'd rather not. I'd rather graph a whole number. All right, so let's plug in negative 4. That's 16. Half of it's 8, and then it's negative 8. All right. So negative 4 squared is 16. And when I multiply it by negative 1/2, I get negative 8. That's where this comes from. Negative 2 squared is 4 times 1/2 is 2, and it's negative. So negative 2. 0 gives me 0. All right. In these cases, 0 is always going to give me 0. 2 gives me negative 2 as well, and 4 gives me negative 8. All right, so the negative 8s aren't going to graph well, but the 0 will, and the negative 2 will, and the positive 2 negative 2 will. So look, see how it's wider? All right, so here is x squared. So what's this one doing? This one is opening down, x-axis reflection. All right, compared to this guy, he's opening down, which is the x-axis reflection. It's reflecting over the x-axis. All right, what else is it doing? It's wider. What's the right term for that? Vertical shrink. All right. 5x squared. What's this guy going to do? He's going to open up or down. No negative, so he's going to open up. So here's x squared right here. All right. This is x squared. 1, 1. And 2, 4. Okay. It's not perfect. It's fine. All right. What do you think this guy's going to do? Well, he's going to open up, and he's going to be a stretch, which means skinny, narrow. All right. So it's going to be inside here. So it's going to go way up really fast. All right. So if I plug in 1, what do I get? 1 times 5. I get 5. All right. 1, 5. So instead of hitting 1, 1, it's going to hit 1, 5, and then it's going to go up from there. So look at the difference. It's a vertical stretch because it's inside here. It's tinier. It's narrower. Vertical stretch. All right, here's x squared. Here's 5x squared. Can you see the difference? All I really needed to do was plug in 1 and go to 5. Boom. That's my point. 1, 5. And negative 1, 5. Because when I square negative 1, I get positive 1. And when I multiply it by 5, I get 5. So those are my 2 points. The only 2 points I really need are 0, zeros. All right. What about this one? 1/3 x squared. Again, that's not a good one. All right. 1, 1, negative 1, 1, 2, 1, 1, 2, 3, 2, 0, 0. All right. So here is x squared. This is y equals x squared. All right. So is this going to be narrow? Is this going to be inside? Or is this going to be outside? It's going to be outside. Right. So it's going to be out here somewhere. So what would I plug in? A nice number that gives me a 1/3. Okay. 1 squared is 1 times 1/3. Yuck. 2 squared is 4 times 1/3 is 4/3. Yuck. 3 squared is 9. 9 times 1/3 is 3. Look, check it out. All right. So 3 squared, and I take 1/3 of it. So I'm going to let x equal 3. I square it. That's 9. 9 divided by 3 is 3. I get 3, 3. All right. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, All right, so you see how it kind of gets wider? All right, so it's wider. So what's the technical term for that? A shrink. Think of this as shrinking, like a flower that would shrink away from whatever it's shrinking away from. Opening up, shrinking. All right, shrinking away from the y-axis is actually what it's doing. So here's x squared, here's 1/3 x squared. All right, this is going to open down, x-axis reflection. If you see a negative, it's going to be an x-axis reflection. All right, and it's going to be narrow, which the technical term is a stretch. All right, so just real quick, if I have y equals x squared right here, boom, this is going to be narrow. I mean, wider. I was wrong. Sorry. Erase, 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 not narrow. It's going to be wider, which is a shrink. How many of you caught that? All right. It's less than 1. 1/4 is less than 1. So it's going to be wider, which is a shrink, which is what this is. I drew it right. I just said it wrong. I apologize. I'm an idiot. All right. That is all. Fair warning, you only get 1 check on your homework. All right. Because it's all just single clicks. Can't just let people go willy-nilly. You gotta have some brain power going on here. So good luck. I will be available. Some of you are not going to like that. I know it. I always get a bunch of feedback about hating limited on the clicks, on the checks. So best of luck. See ya.